Very good morning, students. So today we are going to discuss about diagrammatic and graphic presentation of data, right? See, in the previous concepts we have seen classification and tabulation where all the numerical values are included in it, isn't it? Frequency distribution tables as well as tabulation formation, so with or without numericals. So all those things we have calculated, means where the numbers are included which are not much interesting in. Now how the diagrammatic and graphical representation are more important in statistical data and statistical analyzing part. At the same time, what are the needs? So that we are going to discuss about in this video. So diagrammatic and graphic representation of data. First one, importance and need of diagrams. As you all know that these diagrammatical, they are more attractive. See, generally for any common man, rather than showing the numbers, if you represent the data in terms of graphs or diagrams, it will be easily attractive kind of nature. At the same time, you can remember for a longer period of time also, because numbers and the calculations, mathematical part, definitely it takes little time to remember. But wherein diagrammatical and graphical representation, it is very easy to remember and keeping for a longer time also. Remember that. Clear, guys? See, diagrammatically if you represent, that will be more attractive than the numbers usually. Now they are attractive, hence diagrams and graphs are commonly used. See, whenever you see any newspapers or any kind of magazines and all, usually the data will be representing in terms of diagrams or graphs, because not only the business analyst to understand that or the statistician, even a common man, if they observe it, it should be easily understandable. Clear that? Clear, guys? So diagrams are very much attractive. At the same time, they are most commonly used in newspapers, journals, magazines, so and so. Clear, guys? That is the first importance of diagrams and graphs. Second importance is they give bird's eye view. This is a very important. They give bird's eye view. Even a small point also easily we can observe that by showing the diagrams. I mean by representing the data in diagrams and graphs. Third point is, as you all know that statistical study itself, it facilitates comparisons, right? Even the diagrammatical representation also we can facilitate the comparison. That is the third point. And the fourth one is they can be remembered for a longer period of time. Usually rather than numbers, diagrammatical or graphical representation can be fixed in your mind, I mean remembered for a longer period of time. Remember that. Clear, guys? Next, the third point is it can be easily understood by a common man. As I said, right? It's not only a statistician should understand that, even a common man, if you observe the data, definitely it will be easily understood. Clear? Now quickly just once have a glance. What are the importance or needs of diagrams? Point number one, they are attractive and they are very much used in magazines, newspapers, journals, etc. Point number two, it facilitates comparisons. Point number three, it gives a bird's eye view of the data. Point number four, it can be remembered for a longer period of time. Point number five, it is understood by a layman, common man. Clear, guys? So these are the 5 needs of diagrams and graphs. Coming to the next one, general rules for constructing diagrams and graphs. See, every diagram should have the first rule, title. Title decides the entire data. Identity it gives. Title. Clear? What exactly you are representing. By seeing the data, I mean by seeing the title itself, it can be easily understandable what kind of diagram you are presenting, for what data, for what kind of numerical data. So obviously for diagrams and graphs, tabulation is needed, right? Using the tabulation, they are representing those numerical facts in terms of diagrams or graphs. Clear, guys? Now, any kind of diagrammatical or graphical representation, first and foremost, you need to put the title. Title should always be in a block or capital letters, as you all know that. Clear? So title is very much needed. That is the first basic rule for constructing diagrams and graphs. Second basic rule is proper scale has to be taken, right? Size, scale. x-axis, y-axis. Usually diagrammatical representation can be drawn in any paper, but wherein graphical representation must be drawn in graph sheets only, right? Whenever you are drawing in graph sheets, definitely scale is needed. Remember, both x-axis and y-axis, what measures you are going to take up, so those proper scale has to be taken. That is a second common rule. Rule number 3, it should be neat and attractive. Usually diagrams must be neat and attractive because it should be understandable by a common man easily by seeing the data, by seeing the diagrammatical or graphical representation. Next, point number 4, it should not be overloaded with heavy information, isn't it? As I said, definitely if the data is vast, voluminous, make out number of diagrams by taking the common characteristic. Clear, guys? So it should not be overloaded. Remember. So point number 1 is a title. Point number 2 is a proper scale has to be taken. Point number 3 is like it should not be overloaded with heavy information. Point number 4 is it should be a neat and attractive kind of nature, the diagrammatical representation. Next one is the diagram indicates different parts. Sometimes we have to subdivide the segments, sectors, right? So different parts are to be taken as we have taken the title and then scale, and then on x-axis what measures you have taken, on y-axis what measures you have taken, the qualitative information must be written, the parts, and after representing the diagram, shading it, and then proper index have to be taken, what shaded for what, right? All these information must be taken up. Next one, it should be complete in all aspects. At the same time, it is very simple and self-explanatory, right? So diagrammatical representation, by seeing it, it should be a self-explanatory. Definitely, because why you are representing the diagrammatical representation? Because it should be understood by everybody. At the same time, as we fed up with the numbers, always dealing analysis, always dealing with the calculations and all, showing it in a diagrammatical representation, definitely it will be more attractive and connecting to that point immediately, because diagrammatical and graphical representations will definitely connect it easily than the numbers representing the data. Are you clear? So those are all the general rules for constructing diagrams and graphs. Next, types of diagrams. So in practice, very large variety of diagrams are in use and new ones are constantly being added. So there are divided into actually 4 types. I think many are there, but in our syllabus we confine to only these 2, one-dimensional diagram and two-dimensional diagram. What do you mean by one dimension? One-dimensional diagram. See, as you all know that diagrams can be drawn in any paper, a plain paper or ruled paper or sheet, whatever it is. But graphs must be drawn on graph sheet alone. Remember this. Clear, guys? Next, types of diagrams are of generally 4. One-dimensional, two-dimensional, three-dimensional, pictograms and cartograms, etc. There are many, but we confine it to only 2 methods, that is one dimension and two-dimensional diagrams in our syllabus. Let us see one-dimensional diagram. What do you mean by one-dimensional diagram? The diagram which represents only one dimension, that is either height or width. Remember, height or the width. So width should be taken height proportional to the values it can be drawn without taking the scale, isn't it? So only one dimension it follows, either height or width, right? One-dimensional diagram, only height or width, one dimension if the data represents, that itself called as a one-dimensional. Two-dimensional means both height as well as width. Remember, height and width together if you represent, that becomes two-dimensional. Either height or width, one dimension if you represent, that becomes one-dimensional diagram. So there are 4 different types of one-dimensional diagrams. They are bar diagrams, especially one-dimensional diagrams are called bar diagrams. Those bar diagrams are of 4. One is simple bar diagram, component, nothing but subdivided bar diagram, percentage bar diagram, multiple bar diagram. Multiple, another name is compound bar diagram. I repeat once again, simple bar diagram, component or subdivided bar diagram, percentage bar diagram, multiple bar diagram or compound bar diagram. So all these bar diagrams are one-dimensional diagrams. Remember guys. So one-dimensional means you know that, right? All the bar diagrams, width doesn't matter, only the height matters. Length of the bar requires, but not the width, isn't it? Right? But whereas you are taking the rectangular bars, right? Most probably, possibly you take it as an equal bars, but width doesn't matter because it's a one dimension. Only the height matters. Coming to two-dimensional diagrams, they're all two dimensions, like both height as well as width. When it comes to the pie diagrams, radius, the circle, the radius also must be considered, because as we have not particular about the radius of making the circle, directly we have drawn it, but usually it's a two-dimensional, right? How the protractor keeping and measuring the degrees within 360, right? Those are to be calculated. Accordingly, we have to plot them and join them to the center point, right? And making the sectors and writing the index of it with all the respects. It's a two-dimensional. Histogram, frequency, polygon, curve, as well as ossiles. Ossiles are nothing but cumulative frequency, cumulative curves, right? Cumulative frequency curves, less than ossile and more than ossile. Less than ossile you have to take it as upper limits and LCFs. More than ossile you have to take it as lower limits and MCFs. More than cumulative frequencies. You know, less than cumulative, go on added up. More than frequencies from the total, go on subtracting it. So these are the two methods. One dimension and two-dimensional diagrams. So practice all these diagrams guys, because all these diagrams definitely one question will come for 5 marks, which is very very important. In every paper, without bar diagram there is no question paper. Are you clear? So please practice all the 4 bar diagrams, and here pie diagrams, histogram, frequency polygon and the frequency curve, ossiles. Even these are also important. From these also there will be one question. Remember. So there are totally 2 questions from these two. One dimension, one question. Two dimension, one question. Both for 5 marks each. And 1 mark, 2 marks we have many questions. So needs of diagrams and graphs, needs or uses or importance, and general rules for constructing diagrams and graphs. How many types of diagrams, what is one-dimensional diagram, what is two-dimensional diagram. So all these are very very important. Are you clear guys? Right? So please practice both these methods. In the coming video, I'll be showing it some problems, most frequently asked questions, problems from all the chapters, whatever I have completed so far. From the tabulation, classification and tabulation also we have 5 mark problems with or without numericals, the tabulation form. And here also we have problems in diagrammatical and graphical representation, both one-dimensional and two-dimensional diagrams. Right? See, this histogram, curve, polygon, ossiles, these four are graphical representations, remember. And this one is normally it can be drawn in a plain paper. So with this, I am going to wind up this session. Let us meet in the next video having some problems from tabulation and classification as well as diagrammatical and graphical representation, most frequently asked questions. So stay home, stay safe. Thank you.